Hey there, cool chemistry coyotes. It's Miss DeAngelis again. Today we're going to go over some features about chemical equations. I know there's still a little bit of confusion out there, so I want to take the opportunity to review products, reactants, and the law of conservation of mass. Okay, so let's talk about chemical equations. So they are a representation of a chemical reaction using symbols of the elements. So for example, carbon is C, hydrogen is H. So again, we're going to refer to the periodic table and we're going to look at the name of the element and then also see what the chemical symbol is for the element. And it is an uppercase letter and sometimes it's an upper and a lowercase letter. It's a quick and easy way to show a chemical reaction using symbols instead of words. And there are two sides to a chemical equation. The other day, I first introduced to you reactants and products. The reactants are like the ingredients, and the products are the finished product. So, for example, the ingredients that we use to make brownies, and then once we put them in the oven, which is represented by the arrow, we ended up with brownies. So here we go. The chemical equation for photosynthesis is 6CO2, so 6 molecules of carbon dioxide plus 6 molecules of water, which is H2O, will yield C6H12O6, which is a sugar, and it gives off 6 molecules of oxygen. So that is a balanced equation. So let's talk about reactants. So reactants are the elements or compounds on the left side of a chemical equation. Again, please understand it is the left side of the chemical equation before the arrow. It's present before a reaction takes place. And again, they are the ingredients of a chemical reaction. So if we look at the equation for photosynthesis, you'll understand that the reactants, again, are on the left side of the equation. Okay, they're on the left side of the arrow. It's what we start with. What are the products? The products are the elements or compounds on the right side of a chemical equation. It's what we end up with after the chemical reaction occurs. It's present after a reaction takes place. New substances formed by a chemical reaction. So this is the result. Okay, it is the result. So you notice now the products here highlighted in green are the sugar plus 6 molecules of oxygen. So C6H12O6 is a sugar. The sugar that we intake is C12H22O11, I'm pretty sure. So don't quote me on that one. Okay, so what's the RAP strategy? RAP strategy is reactants and then the arrow and then the products. So again, reactants, then arrow, then products. So RAP. That's one thing you need to remember for your quizzes and your tests. So if we look at this equation, we know that the reactants are on the left. We know the arrow is right in the middle, and we know the products are on the right. So what does the law of conservation of mass state? It states that matter cannot be created or destroyed, that the mass on the reactant side has to equal the mass on the product side. So again, the mass of what you start with has to equal the mass of what you end up with. So if you begin a reaction with 100 grams of substances, you end up with the same amount. So CaO plus CO2 is going to give you CaCO3. CaCO3, guys, is chalk. So just to let you know, that's the equation for chalk. So if we have 40 grams of CaO plus 60 grams of CO2, we should ultimately end up with 100 grams of chalk. So let's talk about balanced or unbalanced equations. So chemical equations must be balanced in order to follow the law of conservation of mass. So we need to find the number of atoms of each element on the reactant side. We need to find the number of atoms of each element on the product side. And if the number of atoms of each element are the same on the reactant and the product side, then the equation is balanced. So if the number of atoms of each element are not the same, then the equation is not balanced, or we say it's unbalanced. So let's look at an example. So example number 1, here's your first example. So I think what we should do is, let's give it a title, total atoms of each element on the reactant side. So notice the coefficient, 4, that's in front of NH4. So we have 4 nitrogen. 4 times the 4 subscript for hydrogen is going to give us 16, and 5 times 3 for oxygen is going to give us 15. Let's look at the reactant side, the product side. The total atoms of each element on the product side. The first one, we look at the coefficient 4 in front of NO, and that tells us that we have 4 nitrogen. If we look at hydrogen, it's 6 times 2, that's 12. And if we look at oxygen, we are taking the 4 times the 1 subscript, which is 4, and then 6 times the 1 subscript, which is 6, and 4 plus 6 is 10. So is this balanced? Well, let's see. Our nitrogen are equal, but our hydrogen is not equal, neither is our oxygen. So we're going to say it's an unbalanced. This is an unbalanced equation. Let's look at example number 2. So let's get our titles up. The total atoms of each element on the reactant side. The first one we're going to start with is going to be the K. So let's look at the coefficient 2 in the front. That's going to tell us that we have 2 molecules of potassium. 2 times N for nitrogen is going to give us 2 nitrogen, and 2 times 3 for oxygen is going to give us 6. And then we're going to go over and we're going to add the other 3 for the oxygen. And so 6 plus 3 is 9. And then finally, for hydrogen, you notice the subscript 2 down here. So we'll have the 2. And then last but not least, we have carbon, and there's only one for the subscript. So we know carbon is equal to 1. Let's look at the other side now. Let's look at the total atoms of each element on the product side. We know that potassium has 2. Notice the subscript 2. Our carbon is going to be 1. Oh, sorry, let's do nitrogen. Our nitrogen is going to be 2, because notice the molecule 2 that's in the front, the coefficient, that's telling us that we have 2 nitrogen. The next is oxygen. The oxygen is going to be 9. So let's look at the subscript 3. So we have 3 plus 2 times the 3, which is 6. So 6 plus 3 is 9. And our hydrogen is going to be 2, because 2 times the subscript 1 is 2. And our carbon is going to equal 1, because we just have a subscript of 1. So is this balanced or unbalanced? Well, let's see. We have 2 potassium on both sides. We have 2 nitrogen on both sides. We have 9 oxygen on both sides, 2 hydrogen on both sides, and the reactant and products match for carbon because it's 1. So I'm going to say it's balanced. Okay, let's go ahead with our checkpoint. Okay, so we're going to do 5 checkpoint questions. I am going to take this part for a grade, participation grade. It says you can discuss it with a partner. However, I want you to work on this independently for this assignment. Take some scratch paper if you need to, so that you can work out each question. And this way, if you are able to come up with a grid like I had created, so that you can identify each element and you can accurately state whether you have a balanced or unbalanced equation. Okay, so question number 1. I want you to identify 1 similarity and 1 difference of the reactants and products in a chemical equation. So what would be 1 similarity and 1 difference? So think about what has to be conserved. So that is something that could be a similarity. And a difference could be maybe they're changing their dance partners. Maybe they're changing who they're bonded to. So that could definitely be a difference. They could just rearrange themselves. So think about that and write your answer, please. Okay, next, question 2. I want you to circle and label the reactants and products in the chemical equation below. I want you to go ahead and circle in different colors and label which ones are the reactants and which side are the products. You don't need to tell me what the names of the atoms are. I just want to know which side is which. For question 3, according to the law of conservation of mass, how many grams of water should be present on the product side? So according to the law of conservation of mass, how many grams of water, or H2O, should be present on the product side? Go ahead and fill in your answer. Question 4, is this equation balanced or unbalanced? What I want you to do is take a scratch piece of paper and I want you to identify each of the elements that you see, plus the corresponding values. I want to know how many atoms for each element are present on the left side and then on the right side, so the reactant side and the product side. And finally, for question 5, you're doing the same thing. I want you to draw the grid. I want you to identify each of the elements and the number of atoms for each element. Look at them and see if they are equal on both sides. If they are, then it's balanced. If it's not, then it's unbalanced. Okay, guys, that's it for this presentation. If you have any questions, I'm always available to help. We're going to be taking a quiz right after this assignment, and I look forward to seeing you guys real soon. Bye.